Your data team is overwhelmed with requests. Business users are waiting days for simple reports. Insights are being missed because asking questions of your data is too technical. Sound familiar? These are the exact problems Microsoft Fabric's AI Skills feature was designed to solve, and it's hiding right inside your current subscription. I've implemented this solution for companies ranging from startups to enterprises, and the results are consistently the same. Democratized data access, faster insights, and freed up technical resources. Today I'm showing you exactly how to set it up, what to watch out for, and the specific ways you can customize AI Skills to work with your unique data environment. The hidden AI skills revolution inside Microsoft Fabric. Did you know there's a set of AI tools hiding right inside Microsoft Fabric that most data teams aren't even using? It's true! Microsoft Fabric has quietly become the fastest growing analytics platform in Microsoft history, with over 19,000 paying customers jumping on board in just a matter of months. But here's the surprising part. Most of these users are only scratching the surface of what's possible with the AI features that come built into the platform. I've spent the last few months talking with dozens of Fabric users at companies of all sizes, and the pattern is clear. About 80% of current users haven't even activated the powerful AI capabilities they're already paying for. These hidden AI tools aren't expensive add-ons or complex extensions. They're already included in your subscription, just waiting to be discovered and put to work. Before we jump into these hidden AI capabilities, let's take a quick look at the chaotic data landscape most companies are facing today. If your organization is like most, you're dealing with data scattered across countless systems, some on-premises, some in various clouds, some in legacy formats that barely connect with anything else. Your marketing team uses one set of tools, finance another, and operations yet another. Getting a complete picture of what's happening across the business often feels impossible. This fragmentation creates massive technical barriers. Data analysts and engineers spend most of their time just trying to connect these disjointed systems rather than actually analyzing the data. I was speaking with a data director at a manufacturing company last week who told me his team spends 70% of their time on data preparation and only 30% on actual analysis. Does that sound familiar? The result? Painfully slow insights. By the time data makes its way through all the technical hurdles and complex processes, the business opportunity it was meant to inform has often already passed. In today's fast-moving markets, waiting days or weeks for critical insights isn't just frustrating, it's a competitive disadvantage. This exact data chaos is precisely why Microsoft built AI directly into Fabric's core architecture. Rather than offering AI as an afterthought or bolt-on feature, Microsoft designed Fabric with artificial intelligence woven throughout the entire platform. The goal wasn't just to add a few smart features, it was to fundamentally transform how organizations work with their data. What makes this approach different is that the AI isn't just for data scientists or technical specialists. Microsoft has specifically designed these capabilities to break down the technical barriers that have traditionally kept business users separated from their data. Instead of waiting for technical teams to build reports or run analyses, Fabric's AI features enable anyone to interact directly with company data in natural, intuitive ways. This shift from technical complexity to AI-powered simplicity isn't just theoretical. It's happening right now in organizations that know where to look. Companies that have activated these hidden AI capabilities are seeing dramatic changes in how quickly insights reach decision makers and how broadly data-driven decisions spread throughout their organizations. For example, one retail chain I worked with recently activated Fabric's AI features across their merchandise planning team. Previously, the team would submit data requests to the analytics group and wait an average of 3 days for results. Now, merchandisers can ask questions directly and get answers in seconds, completely transforming their ability to respond to market changes and inventory issues. At the center of this transformation is one of Fabric's most powerful yet underutilized features, AI Skills. This capability essentially creates a bridge between business language and technical data structures. Instead of requiring users to learn SQL, DAX, or other technical query languages, AI Skills lets them simply ask questions in plain English and get accurate answers directly from their data. Imagine a sales manager typing, "Show me the top 10 customers by revenue in the Southeast region for Q2 compared to Q1." and instantly getting a perfectly formatted table with exactly that information. No coding required, no technical training needed. That's the power of AI skills in action. It makes complex data accessible to everyone, regardless of their technical background. What's particularly impressive about this capability is the speed and accuracy with which it translates natural language into precise database queries. Behind the scenes, AI skills is powered by specialized large language models that have been fine-tuned specifically for data interpretation and query generation. These models understand not just the words in your question, but the intent behind them and how that intent maps to your organization's unique data structures. This natural language capability removes what has historically been the biggest barrier to widespread data adoption: the technical learning curve. When business users needed to learn SQL or other technical skills just to get basic answers from their data, most simply didn't bother. They relied on gut feeling or waited for pre-built reports. AI skills eliminates this barrier entirely, making the full power of your data accessible to everyone who needs it. The impact on organizations can be profound. One healthcare system I consulted with recently reported that after implementing AI skills, the number of employees actively using their data increased by 340% in just 3 months. Data-driven decision-making was no longer limited to analysts and executives. It spread throughout the organization, improving everything from patient scheduling to inventory management. What most current Fabric users don't realize is that this capability isn't some future feature or expensive upgrade. It's already included in their subscription. It just needs to be activated and configured for their specific data environment. Once set up, it becomes an always available AI assistant that grows more valuable as users interact with it. As powerful as AI skills is, it's just the first of many AI capabilities we'll uncover that remain hidden from most Fabric users. Throughout this video, we'll explore several more of these built-in AI features that could transform your data experience almost overnight. From automated data classification to intelligent data preparation to AI-powered visualizations, Microsoft has embedded machine learning and artificial intelligence throughout the platform in ways that most organizations haven't yet discovered. What makes these capabilities particularly valuable is that they work together as an integrated system. The AI features in one part of Fabric communicate and enhance the AI features in other parts, creating a multiplier effect that goes far beyond what any single AI tool could deliver. This integrated approach means that each new AI capability you activate makes all the others more powerful and more personalized to your specific needs. One-line AI magic, the power of AI functions. The integrated nature of Fabric's AI tools creates powerful combinations. But nothing demonstrates this efficiency more dramatically than AI functions. When your colleagues spend a week building text analysis models, how would they react knowing you could accomplish the same task with literally one line of code? These hidden functions connect directly to Microsoft's LLM endpoints, bringing enterprise-grade AI to anyone who can write basic queries. Let me show you what I mean. Typically, if you wanted to analyze the sentiment of customer reviews or social media comments, you'd need to write dozens of lines of code. You'd have to import specific libraries, pre-process your text, connect to an AI service, handle authentication, process the responses, and finally integrate everything back into your dataset. Even for experienced data engineers, this process can take days to get right, especially when dealing with thousands of records. But in Microsoft Fabric notebooks, it's as simple as typing AI sentiment customer comments. That's it. One line and you're done. The system automatically handles all the complexity behind the scenes, instantly returning sentiment scores for your entire dataset. No machine learning expertise required, no complicated setup, just immediate results. What makes this particularly interesting is how these AI functions are built directly into the Fabric environment. They're not add-ons or extensions you need to install. They're already there waiting for you to use them. The functions connect seamlessly to Microsoft's built-in large language model endpoints, giving you access to the same powerful AI that powers tools like Copilot, but specifically optimized for data analysis tasks. These AI functions aren't limited to just sentiment analysis either. You can translate text between languages with AI Translate Text Spanish, or extract key phrases with AI Key Phrases Text, or even categorize text into custom categories you define. All of these capabilities would normally require specialized knowledge in natural language processing and machine learning, but Fabric makes them available through simple function calls anyone can use. What I find particularly clever about how Microsoft implemented this is the compatibility with different data processing methods. Whether you're working with pandas data frames in Python or PySpark for distributed processing of larger datasets, these AI functions work exactly the same way. This means you don't have to change your workflow or learn new syntax based on which processing engine you're using. When you look at the Fabric notebook interface, these AI functions appear right alongside other standard data manipulation commands. They're fully integrated into the code completion system too, so as you type AI, you'll see all the available functions with helpful descriptions. This makes discovering these capabilities much easier, though surprisingly many users still don't realize they exist. What happens behind the scenes when you run one of these functions is pretty interesting too. The system dynamically generates the appropriate code based on your specific dataset and the processing engine you're using. It handles all the connection details, authentication, request formatting, and response processing automatically. For data engineers who've spent hours debugging these kinds of integration points, this automation is a massive time saver. Let me give you a practical example of how this might work in a real business scenario. Say you're analyzing customer support tickets. With traditional methods, extracting insights from thousands of text comments would be a major project. You'd need to clean the text, build sentiment models, create categorization rules, and probably write hundreds of lines of code. The integrated nature of Fabric's AI tools creates powerful combinations, but nothing demonstrates this efficiency more dramatically than AI functions. When your colleagues spend a week building text analysis models, how would they react, knowing you could accomplish the same task with literally one line of code? These hidden functions connect directly to Microsoft's LLM endpoints, bringing enterprise-grade AI to anyone who can write basic queries. Let me show you what I mean. Typically, if you wanted to analyze the sentiment of customer reviews or social media comments, you'd need to write dozens of lines of code. You'd have to import specific libraries, pre-process your text, connect to an AI service, handle authentication, process the responses, and finally integrate everything back into your dataset. Even for experienced data engineers, this process can take days to get right, especially when dealing with thousands of records. But in Microsoft Fabric notebooks, it's as simple as typing AI sentiment customer comments. That's it. One line and you're done. The system automatically handles all the complexity behind the scenes, instantly returning sentiment scores for your entire dataset. No machine learning expertise required. No complicated setup, just immediate results. What makes this particularly interesting is how these AI functions are built directly into the Fabric environment. They're not add-ons or extensions you need to install. They're already there waiting for you to use them. The functions connect seamlessly to Microsoft's built-in large language model endpoints, giving you access to the same powerful AI that powers tools like Copilot, but specifically optimized for data analysis tasks. These AI functions aren't limited to just sentiment analysis either. You can translate text between languages with AI Translate Text Spanish, or extract key phrases with AI Key Phrases Text, or even categorize text into custom categories you define. All of these capabilities would normally require specialized knowledge in natural language processing and machine learning, but Fabric makes them available through simple function calls anyone can use. What I find particularly clever about how Microsoft implemented this is the compatibility with different data processing methods. Whether you're working with pandas data frames in Python or PySpark for distributed processing of larger data sets, these AI functions work exactly the same way. This means you don't have to change your workflow or learn new syntax based on which processing engine you're using. When you look at the Fabric notebook interface, these AI functions appear right alongside other standard data manipulation commands. They're fully integrated into the code completion system too, so as you type AI, you'll see all the available functions with helpful descriptions. This makes discovering these capabilities much easier, though surprisingly many users still don't realize they exist. What happens behind the scenes when you run one of these functions is pretty interesting too. The system dynamically generates the appropriate code based on your specific dataset and the processing engine you're using. It handles all the connection details, authentication, request formatting, and response processing automatically. For Data engineers who've spent hours debugging these kinds of integration points, this automation is a massive time saver. Let me give you a practical example of how this might work in a real business scenario. Say you're analyzing customer support tickets. With traditional methods, extracting insights from thousands of text comments would be a major project. You'd need to clean the text, build sentiment models, create categorization rules, and probably write hundreds of lines of code. From English to SQL, how AI skills transforms questions into queries. Those sample notebooks are great for developers, but they don't solve the fundamental problem facing most organizations, the bottleneck created when business users must wait for technical teams to write queries for them. What if Fabric could transform what were our top-selling products last quarter directly into executable SQL without anyone writing a single line of code? That's exactly what AI Skills does in Microsoft Fabric. It acts as a translator between everyday business language and technical database queries. Think about your organization for a moment. How many business questions go unanswered because your data team is backlogged with report requests? Or how often do simple questions take days to answer because the person who needs the information doesn't know how to write SQL? AI Skills eliminates this barrier completely. The system uses specialized large language models that have been specifically trained to understand natural language questions about data and convert them into perfectly structured T-SQL queries. This isn't just a simple translation tool. It's an intelligent system that understands context, business terminology, and the structure of your data. Let me walk you through how it works in practice. When you access the AI Skills feature in Fabric, you are presented with a simple interface that looks more like a search bar than a development environment. You type your question, something like, show me customer retention rates by region for the last 12 months. And the AI analyzes what you're asking. Behind the scenes, the system is doing something remarkable. It's evaluating your question, understanding the business context, analyzing your data structure, and generating a syntactically correct T-SQL query that will retrieve exactly the information you requested. All of this happens in seconds, not the hours or days it might take to get on a data analyst's calendar. What makes this particularly powerful is that users can provide custom instructions to fine-tune how the AI interprets their specific business language. For example, if your company has unique terminology for customer segments or product categories, you can teach the AI these terms through examples and instructions. You might explain that in your business, premium clients refers to customers who spend more than $10,000 annually, and the system will incorporate this understanding into future query generations. The results appear in a clean visual format that business users can understand, but with full transparency. You can see the exact SQL query that was generated, which builds trust in the system and helps technically minded users verify the accuracy of what's happening behind the scenes. This transparency is crucial for adoption, as it allows data professionals to validate that the correct data is being accessed and manipulated appropriately. What's particularly impressive is the system's ability to handle complexity. It's not limited to simple queries like count all customers. The AI can generate sophisticated SQL that includes multiple joins across tables, complex filtering conditions, date-based calculations, and aggregations that would normally require significant SQL expertise to write manually. For example, you could ask, what's the average order value for returning customers compared to first-time buyers broken down by product category and marketing channel for the past 6 quarters? Try writing that SQL query from scratch. It would take even an experienced data analyst some time to put together correctly. With AI Skills, you get a properly structured query in seconds. The implications for business agility are enormous. Decision makers no longer need to wait in line for technical resources to access their data. Marketing teams can analyze campaign performance on the fly. Sales leaders can explore territory performance without scheduling time with analysts. Finance teams can investigate cost anomalies the moment they appear. However, there are some important limitations to understand. Currently, AI Skills only works with lakehouse and warehouse data sources within the Microsoft Fabric environment. If your data lives in other systems, you'll need to bring it into one of these sources first. This isn't necessarily a problem if you're already consolidating your data in Fabric, but it's something to be aware of if you're working with distributed data sources. Another consideration is the capacity requirement. To enable AI Skills, Your Fabric workspace needs to be backed by F64 capacity or higher. This represents a more significant investment compared to the entry-level tiers, making it important to calculate ROI before committing. That said, many organizations find that the time savings and increased data utilization quickly justify the additional cost. There's also the matter of data literacy. While AI skills removes the technical barrier of SQL knowledge, users still need to understand what questions are meaningful to ask and how to interpret the results they receive. The system can generate a perfect query, but it can't determine if the question itself is relevant to business goals or if the patterns in the results indicate good or bad performance. Security and governance considerations remain important too. Just because users can access data more easily doesn't mean they should have unrestricted access to everything. Organizations need to maintain appropriate data governance practices, ensuring that sensitive information remains protected even as access becomes more democratized. The quality of results also depends on how well your data is structured and documented. If table relationships aren't clearly defined or column names are cryptic, the AI may struggle to generate accurate queries. This actually creates a virtuous cycle. Companies that invest in better data organization to support AI skills end up with more maintainable data assets overall. Despite these considerations, the value proposition is compelling. In one financial services company, the implementation of AI skills reduced the average time to answer business questions from 3 days to just minutes. Their data team reported an 80% reduction in ad hoc query requests, allowing them to focus on more strategic data initiatives instead of constantly writing one-off reports. A retail organization found that after implementing AI skills, the number of employees actively using data in decision-making increased by 340% in just 6 months. This dramatic increase in data engagement led to more informed inventory management and marketing decisions, directly impacting the bottom line. What's particularly interesting is how this capability changes the relationship between business and technical teams. Rather than creating a divide, it often leads to more productive collaboration. Business users bring questions and context, while data professionals focus on ensuring the data foundation is solid, the results are accurate, and governance is maintained. For data professionals concerned about being replaced, the reality is quite different. AI skills doesn't eliminate the need for data expertise, it elevates it. Data engineers and analysts spend less time on routine query writing and more time on data architecture, advanced analytics, and ensuring data quality. It's about working at a higher level of impact rather than being replaced. Now, the AI-powered data transformation journey. This elevation of data professionals through AI is powerful, but it's only the beginning of what's possible. Microsoft Fabric has integrated AI at every single stage of the data pipeline, potentially eliminating countless hours of technical work while dramatically accelerating time to insight for your organization. The true transformation happens when you stop thinking about AI as a feature and start seeing it as the foundation that powers every step in your data journey. Most organizations today operate with a fragmented data ecosystem. You've got one tool for extraction, another for transformation, a different one for storage, yet another for analysis, and something else entirely for visualization. Each transition point creates friction. Data formats need to be converted, permissions need to be reset, and expertise in multiple systems is required. This disjointed approach is why so many data projects take months instead of days. Microsoft Fabric reimagines this entire process by embedding AI throughout every touch point. Think about what this means for your teams. Instead of needing specialists at each stage who hand off work to the next group, you've got a seamless experience where artificial intelligence bridges the technical gaps automatically. The journey begins with Data Factory, which serves as your data ingestion and integration hub. Most people don't realize that AI is already working here, helping parse and understand incoming data. With over 180 connectors to various data sources, the system can automatically detect schemas, identify data types, and suggest optimal integration patterns. For example, when connecting to a CRM system, Fabric's AI can recognize customer records and suggest appropriate transformations without requiring manual mapping of every field. The system can also identify potential data quality issues during ingestion. Rather than discovering problematic records after they've contaminated your data lake, AI flags anomalies immediately. One manufacturing client found that this early detection capability alone reduced their data cleansing time by 65%, allowing them to trust incoming information without extensive manual verification. Once data flows into the system, it lands in OneLake, which functions as a unified storage layer. But OneLake isn't just passive storage. Its AI-powered catalog automatically categorizes, tags, and indexes your data. The system can recognize patterns in files and tables, suggesting appropriate metadata, and making your data discoverable by business users without requiring manual documentation. The AI doesn't just tag data with basic information. It understands context. A text field containing numbers like 555, 123, 4567 is automatically identified as a phone number rather than just being classified as a string. Customer identifiers are recognized across disparate systems, even when formatting differs. This intelligent cataloging means users can search for information using business terminology rather than knowing exact table names or file locations. For data engineers working with this information, AI accelerates the enrichment process. You've already seen how AI functions simplify text analysis with a single line of code, but the impact goes deeper. These enrichment capabilities extend to various data types. Geographic information can be enhanced with demographic insights, temporal data can reveal seasonal patterns, and numerical data can undergo statistical analysis with minimal coding. One retail organization used these capabilities to analyze years of customer reviews across multiple platforms. Instead of spending weeks writing custom code for sentiment analysis, entity extraction, and categorization, they applied Fabric's AI functions in minutes. The system automatically identified product mentions, extracted feature preferences, and tracked sentiment changes over time. This analysis led to specific product improvements that increased customer satisfaction by 23% in the following quarter. In the data warehouse environment, AI transforms how teams interact with structured data. Copilot steps in to assist with query development, schema design, and optimization suggestions. Even experienced database professionals benefit from AI-generated suggestions for complex joins or performance improvements. For those less familiar with SQL, Copilot can generate entire queries based on natural language descriptions of the desired output. A healthcare provider leveraged this capability to analyze patient readmission patterns. Their clinical staff needed to understand factors contributing to readmissions but lacked SQL expertise. Using Copilot, they described what they wanted to analyze in plain English, and the system generated appropriate queries. This democratization of data access meant clinical insights could be discovered directly by those with the domain knowledge rather than relying on back-and-forth communication with database specialists. As data moves into the analytics phase, AI continues to add value through automatic pattern detection. The system can identify relationships between variables that might not be obvious to human analysts. For example, a financial services company discovered unexpected correlations between customer service interactions and product adoption rates that weren't visible in standard reports. These AI-detected patterns led to targeted service improvements that increased cross-selling success by 18%. The transformation journey culminates in Power BI, where AI powers the visualization and exploration experience. Copilot can now create entire reports based on verbal descriptions, suggesting appropriate visualizations and layouts based on the data characteristics. The system understands which chart types work best for different analysis scenarios, using bar charts for comparisons, line charts for trends, and scatter plots for correlations. Beyond automated report creation, Copilot extends into semantic model creation. This critical layer that defines relationships, metrics, and business logic can now be generated and refined through natural language interaction. Instead of manually defining DAX measures, users can describe what they want to calculate, and the AI creates optimized formulas. This capability significantly reduces the technical barrier to creating well-structured data models. Perhaps most importantly, the natural language interaction in Power BI creates a truly conversational experience with data. Users can ask follow-up questions, drill into specific areas, and refine their analysis without needing to understand the underlying query language. This continuous conversation with data means insights emerge through exploration rather than being limited to predefined reports. A consumer goods manufacturer implemented this end-to-end AI approach and transformed their decision-making process. Previously, market analysis required coordination between 4 separate teams and typically took 3 weeks to complete. With Fabric's integrated AI capabilities, the same analysis now happens automatically with daily updates. Business users can explore the latest market trends, test hypotheses, and make decisions based on current information rather than waiting for periodic reports. This transformation required rethinking how their data teams operated. Rather than organizing around technical specialties, ETL developers, database administrators, report developers, they restructured around business domains. Cross-functional teams with mixed technical skills supported specific business areas, with AI handling many of the technical integration points that previously required specialized expertise. Supercharging performance, the Spark native execution engine. Cross-functional teams supported by AI certainly accelerate insights, but there's still a fundamental physics problem in data processing that no amount of teamwork can solve. The new Spark native execution engine in Microsoft Fabric tackles this head-on, yet surprisingly few users have enabled this free performance boost that could quadruple your processing speed. You know those moments when you're waiting for a large data set to process and it feels like you could go make coffee, take lunch, or maybe even go home for the day? That waiting time isn't just frustrating, it's expensive. When business leaders are waiting hours or even days for answers to their questions, opportunities slip away and decisions get delayed. This is exactly why Microsoft developed a new execution engine that dramatically changes the game. The Spark native execution engine became generally available with Fabric Runtime 1.3, and it's one of those rare technological advancements that delivers massive improvements without requiring you to change your existing code. This update includes Spark 3.5 and Delta 3.2 with powerful features like liquid clustering that optimize how data is stored and processed. But what makes this so special compared to typical performance upgrades? Most performance improvements in the data world follow a predictable pattern. You pay more, you get more. Want faster processing? Upgrade your hardware? Need quicker query responses? Add more compute capacity. But the native execution engine breaks this pattern by offering dramatically improved performance at absolutely no additional cost to existing Fabric customers. It's literally a free speed boost waiting to be activated. The engineering behind this improvement focuses on how Spark processes data in a cloud environment. Traditional Spark implementations weren't originally designed for cloud architectures, creating inefficiencies when running at scale. Microsoft's team redesigned key components to eliminate these bottlenecks, resulting in a much more efficient execution path for data processing jobs. What's particularly impressive is how the performance gains scale with complexity. Simple queries might see modest improvements, but when you're dealing with complex data transformations involving multiple joins, aggregations, and calculations across large datasets, that's where you'll see the most dramatic speed increases. I've talked with data engineers who reported processing jobs that previously took 4 or 5 hours, now completing in just over an hour after enabling the native engine. Take the example of a retail analytics team that processes daily sales data from thousands of stores. Before enabling the native execution engine, their end-of-day processing job took nearly 3 hours to complete, meaning business users couldn't access updated reports until the next morning. After activating the new engine, the same job finished in 46 minutes, without changing a single line of code. This meant decision makers could see their daily performance metrics before leaving work, completely changing their ability to respond to market trends. Or consider a financial services company that runs risk analysis models against their transaction data. Their weekly risk assessment process typically ran for 26 hours over the weekend. After enabling the native execution engine, they completed the same analysis in just under 7 hours. This not only saved computing resources, but also gave them the option to run these analyses more frequently, improving their risk management capabilities. The benefits extend beyond just raw speed. When processing jobs complete faster, they consume fewer resources, which means your existing capacity can handle more concurrent workloads. Teams that previously had to carefully schedule their processing jobs to avoid conflicts can now run more jobs simultaneously, increasing overall productivity and responsiveness. Enabling this performance boost is surprisingly straightforward. You'll need to update to at least Fabric Runtime 1.3 if you haven't already, And then enable the native execution engine in your workspace settings. For most workloads, you don't need to modify your existing notebooks or processing scripts. The engine handles the optimization automatically. There are a few technical considerations to be aware of. The native execution engine is optimized for larger datasets where the performance improvements become most noticeable. For very small datasets, the difference might be minimal. Additionally, while the engine is compatible with most existing Spark code, there are some advanced Spark features and third-party libraries that might not be fully optimized yet. The real question is, why haven't more organizations enabled this feature? The adoption rate remains surprisingly low, with many Fabric workspaces still running on the standard execution engine. Based on conversations with data teams, there seem to be three main barriers to adoption. First, awareness. Many teams simply don't know this option exists or understand its potential impact. Microsoft has documented the feature, but it hasn't received the same level of attention as some of the more visible AI capabilities. Second, change management concerns. Data engineers are understandably cautious about making changes to production environments, especially when current processes are working reliably. Even though enabling the native execution engine is low risk and reversible, there's still hesitation to modify running systems. Third, testing capacity. Many teams lack the bandwidth to properly test new features before implementing them, so they stick with what they know works rather than exploring potentially better options. But these barriers are relatively easy to overcome. The native execution engine can be tested in development environments before rolling out to production, and the process is fully reversible if any issues arise. More importantly, the potential time savings are substantial enough to justify the minimal effort required to implement the change. One manufacturing company I spoke with had a particularly interesting experience. They were in the process of expanding their data team to handle growing processing demands when they learned about the native execution engine. After implementing it, they found their existing team could handle the increased workload without additional headcount, saving them over $300,000 in planned hiring costs. Not every performance improvement will be that dramatic, but even modest gains add up quickly when applied across your entire data operation. If your teams are processing data daily or hourly, a 75% reduction in processing time translates to significant operational improvements and much more responsive analytics. The native execution engine represents a fundamental shift in how Fabric handles data processing tasks, and it's just the beginning of the performance optimizations Microsoft has planned. Future releases are expected to bring additional improvements, particularly for specific types of workloads like machine learning, model training, and natural language processing. Real-time intelligence, from sensors to insights instantly. The future of data isn't just about processing historical information faster, it's about eliminating the gap between when something happens and when you can act on it. Microsoft Fabric currently processes an astonishing 5.1 billion real-time queries daily, allowing businesses to respond to events as they occur rather than hours or days later. This shift from reactive to proactive analytics represents one of the most significant transformations in how organizations use data, yet remains surprisingly underutilized. Think about the traditional analytics workflow most companies still use today. Something happens in your business, a machine starts malfunctioning, a transaction pattern shifts, or inventory levels drop. Hours or even days later, that data gets collected, processed, analyzed, and finally reaches someone who can act on it. By then, the opportunity to prevent problems has long passed. You're stuck in a cycle of reaction rather than prevention. Real-time intelligence in Microsoft Fabric fundamentally changes this relationship with data. Instead of looking in the rearview mirror at what already happened, you gain the ability to see what's happening right now and, more importantly, what's about to happen next. This capability shifts the entire paradigm from what went wrong yesterday to what's happening right now that needs attention. At the center of this real-time architecture is the Real-Time Hub, a specialized component designed specifically for ingesting streaming data at massive scale. The hub accepts data from an impressive variety of sources, everything from IoT devices and industrial sensors to application logs and business transactions. What makes this particularly powerful is its ability to integrate with both Microsoft's own systems and third-party streaming platforms like Apache Kafka. The flexibility of input sources means organizations don't have to rebuild their entire data architecture to gain real-time capabilities. A manufacturing company can connect existing shop floor sensors directly to Fabric. A retailer can stream point-of-sale transactions as they happen. A logistics company can monitor fleet locations and conditions continuously. The system adapts to your data sources rather than forcing you to adapt to it. Once data streams into the real-time hub, it flows into Event House, the storage and processing layer designed specifically for time series data. What's remarkable about Event House isn't just its massive scale, handling 10 exabytes of events monthly, but its reliability. With 5 nines, 99.999% uptime, it provides the kind of stability needed for mission-critical operations, where even brief outages could mean missed signals and costly consequences. To put that reliability in perspective, 99.999% uptime translates to just over 5 minutes of potential downtime per year. For applications monitoring critical infrastructure, production lines, or financial transactions, this level of reliability isn't just a nice feature, it's an absolute requirement. One of the most innovative components in Fabric's real-time ecosystem is the Digital Twin Builder. This tool allows you to create virtual representations of physical objects, machines, buildings, vehicles, or even entire factories, along with their relationships and behaviors. These digital twins continuously sync with real-world conditions through sensor data, creating a living model of your operations. The power of digital twins comes from how they bridge the physical and digital worlds. When you create a digital twin of a manufacturing line, for example, you're not just collecting data from individual sensors. You're modeling how those components interact as a system. This contextual understanding enables much more sophisticated monitoring and analysis than looking at isolated data points. What's particularly powerful is how these digital twins connect directly to operational dashboards. Plant managers don't need to understand the underlying data architecture to benefit from real-time insights. They simply see a visual representation of their facility with alerts and status indicators, highlighting areas needing attention. This accessibility dramatically increases adoption among non-technical users who previously relied on delayed reports. But perhaps the most transformative element of Fabric's real-time intelligence is Data Activator, the component that moves beyond passive monitoring to active response. Data Activator continuously watches for specific conditions or patterns in your streaming data and automatically triggers actions when thresholds are crossed. These actions can range from simple notifications to complex workflows involving multiple systems. Imagine a retail scenario where inventory levels for a popular product start dropping unusually fast. With traditional analytics, you might discover this trend days later in a weekly report. With real-time intelligence and Data Activator, the system can immediately recognize the pattern, calculate likely stockout timing, and automatically adjust reorder quantities or even initiate emergency shipments from nearby locations, all without human intervention. This automation capability eliminates one of the biggest bottlenecks in data-driven decision-making: human attention. No matter how good your dashboards are, they're only effective when someone is actively looking at them and taking appropriate action. Data Activator ensures critical signals never get missed due to busy schedules, off-hours events, or simple oversight. The potential applications span virtually every industry. Utilities use these capabilities to detect and respond to grid anomalies before they cause outages. Manufacturers catch quality issues on production lines before creating defective products. Financial institutions identify potentially fraudulent transactions and block them in real time. Healthcare providers monitor patient vital signs and alert clinicians to concerning trends before they become emergencies. A transportation company I worked with recently implemented real-time intelligence to monitor their fleet of delivery vehicles. Previously, they'd discover problems like engines overheating or unusual fuel consumption patterns only after drivers reported issues or during scheduled maintenance. By connecting vehicle telematics directly to Fabric's real-time pipeline, they now detect problems as they develop. When unusual engine temperature patterns emerge, the system automatically schedules maintenance appointments and reroutes other vehicles to cover affected deliveries. This prevented dozens of potential breakdowns in the first month alone, saving an estimated $230,000 in emergency repairs and missed deliveries. More importantly, it transformed how the company thinks about vehicle maintenance. moving from a reactive repair model to predictive prevention. Implementing effective real-time analytics does require some architectural adjustments, unlike batch processing, where system performance might dip during processing jobs. Real-time processing must maintain consistent low latency 24/7. This means dedicating appropriate capacity and designing data flows specifically for continuous operation rather than scheduled jobs. Data quality also becomes even more critical in real-time scenarios. With batch processing, data issues can often be caught and corrected before analysis. In real time, bad data can trigger incorrect alerts or actions before anyone notices the problem. This necessitates robust data validation at the ingestion point and clear handling procedures for anomalous inputs. It's also important to carefully design your alerting thresholds and automated actions. Too sensitive, and you'll create alert fatigue with constant notifications. Too conservative, and you'll miss important signals. Finding the right balance requires deep domain knowledge and regular refinement based on actual results. Despite these challenges, the benefits of real-time capabilities far outweigh the implementation complexities. The ability to detect and respond to events as they happen, or even predict them before they occur, creates competitive advantages that simply aren't possible with traditional analytics approaches. OneLake, the AI foundation you didn't know you needed. Real-time intelligence transforms how you respond to data, but beneath every successful AI implementation lies a critical foundation most organizations overlook. OneLake isn't just another storage system, it's solving the number one reason why 70% of AI projects fail: disconnected, incompatible data scattered across dozens of organizational silos. When we talk about AI in Microsoft Fabric, we often focus on the flashy capabilities, those real-time dashboards, natural language queries, and one-line AI functions. But here's the truth that experienced data architects understand. None of those advanced capabilities can work effectively without a unified data foundation. Think about it like building a house. You can have the most beautiful design plans, but if your foundation is cracked and unstable, the entire structure is compromised. This is where OneLake comes in. It's the invisible foundation that makes everything else possible. Unlike traditional data lakes that simply store information, OneLake was built specifically to enable AI-powered analysis across your entire data estate. What makes it special is its ability to create a unified data experience without requiring you to physically move or copy your data from existing systems. Let me show you why this matters. In a typical organization before Fabric, data exists in multiple disconnected systems. Marketing data in one database, finance in another, customer information in a CRM, and operational data spread across various applications. When you try to apply AI across this fragmented landscape, you immediately hit roadblocks. Data formats don't match, security models conflict, and just getting the information into one place for analysis becomes a project requiring weeks of developer time. OneLake solves this by creating what Microsoft calls a logical data lake with a universal format. It's a multi-cloud, SaaS-based data lake that serves as the central connection point for all data within your Fabric environment. The key innovation is that OneLake supports open formats like Delta Parquet and Apache Iceberg, ensuring compatibility with existing tools and preventing the vendor lock-in that's plagued data projects for years. What's particularly important about these open formats is that they maintain data lineage and schema information, which is essential for AI algorithms to properly understand and process your information. When data moves between systems and loses its context, AI tools struggle to make accurate predictions or generate meaningful insights. The open format approach preserves this critical context. One of OneLake's most powerful features is its shortcut system, a unique approach to data sharing that doesn't involve moving or duplicating information. These shortcuts are essentially pointers to data that might physically reside in different locations but appear as if they're all part of the same lake. This dramatically reduces storage costs and eliminates synchronization headaches that have traditionally made data lakes difficult to maintain. The adoption of these shortcuts has been remarkable, with over 3 million already created. Organizations report that their OneLake data volume doubles approximately every 15 weeks, a clear sign that users find tremendous value in this unified approach. What's driving this growth? The ability to finally break down data silos without the massive migration projects that previous solutions required. Security is another critical aspect where OneLake shines. Traditional approaches to data sharing often create security gaps, either by over-restricting access, preventing legitimate use, or by creating copies with inconsistent permissions, leading to potential breaches. OneLake implements a unified security model across all data, regardless of source, ensuring that governance policies are consistently applied. For AI applications, this consistent security model is particularly important. It allows machine learning models to access the broadest possible dataset while still respecting privacy, boundaries, and regulatory requirements. The result is more accurate models trained on more comprehensive data, all without compromising security. Let's look at how this plays out in practice. When a business user asks a natural language question through AI skills, that query needs to securely access data that might come from multiple sources. Without OneLake, each data source would have its own security model, requiring complex authentication flows and potentially blocking critical information. With OneLake, the query can seamlessly run across all relevant data while automatically respecting existing permission structures. Similarly, when data scientists are using AI functions like sentiment analysis or entity extraction, they need to apply these capabilities to text from various systems: customer support tickets, social media posts, product reviews, and internal documents. OneLake makes it possible to run these functions across all these sources without having to build separate pipelines for each one. The technical benefits extend to performance as well. Because OneLake uses a consistent storage format, query optimization becomes much more effective. AI algorithms can take advantage of partitioning, indexing, and caching strategies that wouldn't be possible across disconnected systems. Many organizations report query performance improvements of 40 to 60% simply from centralizing their data in OneLake. But perhaps the most significant advantage is how OneLake transforms the data preparation process. Traditional AI projects spend 70-80% of their time just preparing and cleaning data before any actual analysis can occur. With OneLake, much of this preparation happens automatically through the unified format, dramatically accelerating the time to insight for AI projects. There's another benefit that's easy to overlook. OneLake significantly reduces the cognitive load on both technical and business users. When everyone is working from the same data foundation, there's no need to remember which system contains which information or how to connect disparate sources. This cognitive simplification allows people to focus on the questions they're trying to answer rather than the mechanics of accessing data. I want to be clear that implementing OneLake does require some rethinking of how your organization manages data. The shift from a collection of isolated data islands to a unified lake requires changes in processes, responsibilities, and even organizational structures in some cases. Data stewardship becomes more important, as does having clear governance policies that apply across the entire data estate. However, these changes don't have to happen all at once. Many organizations start by moving just a few key data sets into OneLake, proving the value with specific use cases before expanding further. Others maintain their existing data warehouses and lakes, but use OneLake shortcuts to create a unified layer on top. The flexibility of the approach means you can adopt at your own pace. What's particularly powerful about OneLake is how it enables true data democratization without sacrificing control. Business users can access and analyze information through AI-powered interfaces, while data professionals maintain oversight of quality, security, and compliance. This balance has been difficult to achieve with previous generations of data platforms. Copilot, your AI data assistant, throughout the journey. Data democratization sounds great in theory, but how do non-technical users actually navigate this unified data landscape without getting lost? That's where Fabric's most powerful yet overlooked capability comes into play. While you've probably encountered Copilot in Word or Excel, the version embedded within Microsoft Fabric represents something entirely different. An AI assistant specifically engineered for data work that bridges the gap between technical complexity and business insights. What makes Fabric's implementation of Copilot unique is how deeply it's woven into the data analysis workflow. Unlike the general-purpose assistant you might use to draft emails or summarize documents, Fabric's Copilot understands data relationships, query patterns, and visualization best practices. It's like having a data expert looking over your shoulder, guiding you through each step of your analysis journey. The most immediately useful application appears in Power BI report creation. Instead of the traditional approach of dragging fields onto a canvas and configuring each visual manually, you can now simply describe what you want to see. Imagine typing something like, "Show me monthly sales trends by region with a forecast for the next quarter," and watching as Copilot generates a complete visualization with appropriate chart type, data fields, and even predictive analytics, all formatted according to your company's branding guidelines. This doesn't just save time, it fundamentally changes who can create meaningful reports. Business managers who previously relied on analysts to build visualizations can now independently explore their data and create professional-looking reports without mastering the technical aspects of Power BI. A marketing director at a retail chain reported that her team now creates their own campaign performance dashboards in minutes, rather than waiting days for the analytics team to build them. Where Copilot truly shines is in semantic modeling, the complex process of defining relationships between data tables and creating calculation logic. Traditionally, this required deep technical knowledge of data modeling principles and DAX formula language. Now, Copilot can suggest optimal table relationships based on your data structure, recommend measures for common business metrics, and even help troubleshoot performance issues in your semantic model. For instance, when working with sales and customer data, you might simply ask Copilot to create a calculation for customer lifetime value rather than writing the complex DAX formulas yourself. Not only will it generate the measure, but it will explain its approach and suggest refinements based on your specific data patterns. This dramatically accelerates the modeling process while making it accessible to analysts with limited DAX expertise. The conversation doesn't end with report creation. The natural language querying capabilities extend to data exploration, where users can ask follow-up questions and drill into specific areas of interest without writing a single line of code. This conversational approach matches how business users naturally think about data problems in terms of questions rather than queries. A financial analyst might start with, "What were our top-performing products last quarter?" and then naturally follow up with, "How did they perform compared to the same quarter last year? And which customer segments drove most of that growth?" Each question builds on the context of previous queries, creating a flowing conversation with your data rather than a series of disconnected technical commands. The integration of Copilot throughout the Fabric environment creates a consistent experience that guides users, regardless of which part of the platform they're using. This consistency helps reduce the learning curve for new users while making experienced analysts more productive across the entire data lifecycle. One of the most recent additions is the dedicated Copilot button that launches a full-screen experience specifically designed for business users who need quick answers without navigating the complexities of the underlying platform. This focused interface puts conversational AI front and center, removing technical distractions and emphasizing natural language interaction with your data. A healthcare administrator described how this feature transformed their operation. Before, our clinicians would email requests to the analytics team and wait days for reports. Now they can ask Copilot directly about patient flow metrics or resource utilization patterns and get immediate answers. This has completely changed how quickly we can respond to operational challenges. The technical implementation behind these capabilities is sophisticated but invisible to users. Fabric's Copilot leverages specialized large language models that have been fine-tuned on data analysis patterns, business intelligence best practices, and domain-specific terminology. These models understand not just general language, but the specific context and requirements of data work. What's particularly valuable is how Copilot learns from your data environment. As you use it more, it becomes familiar with your specific data structures, naming conventions, and common analysis patterns. This means the suggestions become increasingly relevant to your organization's unique needs rather than generic recommendations. For data professionals concerned about being replaced, it's important to understand that Copilot augments rather than replaces expertise. It handles routine tasks and removes technical barriers, allowing data experts to focus on higher value activities like data strategy, advanced analytics, and ensuring business alignment. A data engineering manager at a manufacturing company noted that after implementing Copilot, her team spent 40% less time on basic report modifications and could finally tackle their backlog of predictive modeling projects. The security model is equally sophisticated. Copilot operates within your existing Fabric security boundaries, meaning users only see results and suggestions based on data they already have permission to access. This maintains your governance controls while democratizing data access. There are some limitations worth noting. The quality of Copilot's assistance depends significantly on how well your data is structured and documented. Organizations with poorly named fields, unclear relationships, or inconsistent metadata will find Copilot less effective until those foundational issues are addressed. Additionally, while Copilot can generate complex DAX measures and queries, it may sometimes require refinement for edge cases or highly specialized calculations. The implementation requirements are straightforward. Copilot capabilities are included with standard Fabric licensing, though some of the more advanced features may require specific capacity levels. Unlike standalone AI tools that require separate subscriptions and integration work, these capabilities come built into the platform you're already using. The capacity catch: what you need to enable AI skills. Let's talk about what specific capacity levels really means in practice. While you might be excited about all these AI capabilities we've discussed, there's a carefully structured pricing model behind them that determines whether you're getting the basic AI experience or the premium version, and the difference in cost might surprise you. Microsoft has created a tiered approach to Fabric's AI features that isn't always clearly explained in their marketing materials. When organizations first dive into Microsoft Fabric, they're often drawn in by the impressive AI demonstrations and case studies showing dramatic productivity improvements. What's less obvious is that accessing these capabilities requires varying levels of computing power measured in what Microsoft calls capacity units. This is the hidden detail that can make or break your implementation budget. The capacity model works on a scale that starts with F2, the smallest, and goes all the way up to F2000, with each tier representing significantly more computing power. What's particularly important to understand is that different AI features become available at different capacity tiers. For example, if you're interested in those basic AI functions we discussed earlier, like sentiment analysis or language translation, you can access those with just F2 capacity, making them reasonably affordable for smaller teams or departments. But here's where things get interesting. If you want to use the full AI skills feature that lets business users ask natural language questions and get SQL queries automatically generated, you'll need to step up to F64 capacity or higher. That's a 32x increase from the entry-level tier. This represents a significant investment that many organizations don't initially factor into their planning when they first get excited about Fabric's capabilities. To put this in perspective, F64 capacity currently costs approximately $32,000 per year. That's a substantial line item that needs proper justification, especially for mid-sized organizations. The pricing structure creates a situation where you might have access to Fabric, but not to its most transformative AI features unless you commit to higher capacity tiers. This capacity requirement isn't arbitrary. The natural language processing and complex query generation happening behind the scenes in AI skills demands substantial computational resources. The system is constantly analyzing your data structure, understanding business terminology, and translating complex business questions into optimized SQL, all of which requires significant processing power. Microsoft does recognize this potential barrier and offers an excellent trial program that provides approximately $17,000 worth of capacity for 2 months. This gives organizations a chance to test the full range of AI capabilities before making a long-term commitment. The trial includes access to F64 capacity, allowing teams to explore AI skills and other advanced features that might otherwise be financially out of reach during an initial evaluation. What's particularly important for planning purposes is understanding the capacity requirements for each feature. Beyond just AI skills, different components of Fabric have their own minimum capacity requirements. For example, some of the real-time processing capabilities require higher tiers to handle the velocity of incoming data. Similarly, using Copilot for advanced semantic model generation benefits from higher capacity tiers for optimal performance. Many organizations adopt a phased approach to managing these capacity requirements. They might start with a smaller F16 capacity to experiment with the core platform and basic AI functions. This allows them to demonstrate value and build internal support before requesting the budget increase needed for F64 capacity to enable the full AI skills capability. A strategic approach that many successful implementations follow is to identify a high-value use case that specifically benefits from AI skills or other advanced features. By focusing on a business problem with clear ROI potential, they can justify the higher capacity investment based on tangible business outcomes rather than the technology itself. For example, a financial services company might start with basic report automation using lower tier capacity, then upgrade to enable AI skills specifically to improve their risk analysis process. By showing how the natural language interface allows analysts to identify potential issues faster, they can quantify the value in terms of reduced risk exposure and regulatory compliance, outcomes that easily justify the increased capacity costs. It's also worth noting that capacity isn't just about enabling features, it affects performance as well. Higher capacity tiers deliver faster query responses and better concurrent user experiences. This becomes particularly important as adoption grows across your organization. What works well for a pilot with 10 users might become frustratingly slow when expanded to 100 users without appropriate capacity scaling. Some organizations get creative with their capacity planning by implementing a hybrid approach. They might maintain a production workspace with lower capacity for routine reporting and analysis, while setting up a separate high-capacity workspace specifically for advanced AI features. This allows them to control costs while still providing access to the full range of capabilities where they deliver the most value. Another consideration is the seasonal nature of some businesses. Retail organizations, for example, might temporarily increase their capacity during peak holiday seasons when faster insights deliver more business value, then scale back during slower periods. Microsoft's capacity model allows for this kind of flexibility with commitments as short as 1 month. When planning your implementation, it's essential to conduct a thorough assessment of which AI capabilities will deliver the most value to your specific business processes. This assessment should include both technical and business stakeholders to ensure alignment between the capacity investment and expected outcomes. The good news is that once you've made the appropriate capacity investment, the AI features themselves don't carry additional per-user fees or usage charges. This creates predictability in your budgeting and allows for broader adoption without incremental costs, a significant advantage compared to many standalone AI tools that charge by the query or user. It's also worth mentioning that Microsoft continues to optimize these features, potentially reducing their capacity requirements over time. What requires F64 today might work with lower capacity tiers in future releases as the underlying technology becomes more efficient. This ongoing optimization is part of Microsoft's commitment to making AI more accessible across their platform. For organizations just starting with Fabric, the recommendation is clear. Begin with the trial to experience the full range of capabilities. Identify the features that deliver the most value for your specific needs, then structure your capacity plan accordingly. This approach allows you to make informed decisions based on actual experience rather than marketing promises. Real-world transformations. How companies are using Fabric's AI today. Beyond the marketing promises and trial periods, organizations are seeing real, measurable transformation in their data practices. What's remarkable is that among Microsoft Fabric's customer base, specific implementation patterns consistently lead to dramatic productivity gains, patterns your organization could follow starting tomorrow. Let's look at what's actually happening in companies that have fully embraced Fabric's AI capabilities. A global manufacturing firm recently shared that after 6 months of implementation, they achieved something they'd been attempting for years, creating a single source of truth for production metrics across 12 facilities. Their VP of Operations explained, before Fabric, each plant had their own reporting systems and metrics. Now, with One Lake and AI-powered data integration, we've unified everything. What's shocking is that plant managers are now checking dashboards on their phones between meetings instead of waiting for weekly reports. This transformation didn't happen by accident. The manufacturing firm followed what's emerging as a common success pattern. They started with a focused business problem rather than a technology-first approach. They identified a specific pain point, inconsistent production metrics across facilities, and targeted Fabric's AI capabilities directly at solving that problem before expanding further. We're seeing this focused approach consistently among successful implementations. A large financial services company didn't try to transform their entire analytics ecosystem overnight. Instead, they targeted their customer service division, where representatives were spending up to 30 minutes preparing for client calls by gathering data from 7 different systems. By implementing Fabric with AI skills, representatives can now ask natural language questions about a client's history moments before a call, reducing preparation time to under 3 minutes. Their director of client services noted, "The ROI was immediate and measurable. Our representatives now spend 84% more time actually talking to clients rather than hunting for information. Client satisfaction scores improved by 27% in just the first quarter after implementation." What's particularly interesting about successful Fabric implementations is how they're redefining job roles within data teams. A major retail chain reorganized their analytics department after activating Fabric's AI capabilities. Where they previously had specialists focused on specific tools, SQL developers, report builders, data warehouse architects, they now organize teams around business domains like inventory management, customer experience, and supply chain optimization. Their chief data officer explained the technical silos made sense when each tool required deep expertise. But with Fabric's AI handling more of the technical complexity, we've shifted to business-focused teams where analysts understand the domain deeply and let AI handle much of the technical implementation. This reorganization is yielding significant benefits. The same retail chain reports that new analytics requests now move from concept to delivery in an average of 4.5 days compared to 23 days before implementation. Perhaps more importantly, about 68% of business questions are now answered by business users themselves without ever creating a ticket for the analytics team. Let's talk about the adoption challenges, because successful implementations didn't happen without overcoming some hurdles. Almost every organization reports initial skepticism from technical teams. A healthcare systems data engineering team initially viewed AI-generated code with suspicion, manually checking every query generated by AI skills. Their lead data engineer admitted, "I was convinced I would need to fix everything the AI produced. After about 3 weeks of consistently solid results, I stopped checking every query and started focusing on more complex data architecture challenges that actually needed my expertise." This highlights another consistent pattern in successful implementations. Organizations allocated time and resources for technical teams to verify and validate AI outputs initially, gradually building trust in the system. The most successful transitions included formal procedures for this validation period rather than forcing immediate adoption. Training emerged as another critical success factor. Organizations that invested in structured training programs saw adoption rates nearly 3 times higher than those relying on documentation alone. A telecommunications company created what they called AI data champions, power users from each business department who received intensive training and then helped their colleagues adopt the new capabilities. Their approach included bi-weekly lunch and learn sessions where business users could bring actual questions they needed answered. The AI data champions would show them how to use AI skills to solve their specific problems in real time. This contextual, problem-focused training drove adoption far more effectively than generic technical tutorials. Security and governance considerations also differentiated successful implementations. A government agency created clear guardrails for their AI implementation, defining which types of data could be accessed through natural language queries and which required traditional approval processes. They implemented a phased approach, starting with less sensitive datasets before gradually expanding access as confidence in the security controls increased. Their approach included mandatory logging of all AI-generated queries with periodic audits to ensure compliance with data access policies. This thoughtful governance approach actually accelerated adoption by giving leadership confidence that sensitive information remained protected. The most successful organizations also recognize that AI implementation is an iterative process. A consumer goods manufacturer scheduled monthly feedback sessions where users could share their experiences, both positive and challenging, with the AI capabilities. They used this feedback to refine custom instructions provided to the AI and to identify areas where additional training was needed. Their director of analytics explained, "We discovered that different business units were using slightly different terminology for the same concepts. By incorporating these variations into our custom instructions, we dramatically improved the accuracy of AI-generated responses across the organization." Several organizations reported unexpected benefits beyond the immediate productivity gains. A utility company discovered that making data more accessible through AI skills led to entirely new types of questions being asked. Their innovation manager noted, "When employees had to submit formal requests for data analysis, they only asked questions they were confident would deliver value. With the barrier removed, we're seeing more exploratory questions that have uncovered several $1 million in operational efficiency opportunities we would have never discovered otherwise." What's particularly encouraging is that these transformative results aren't limited to giant enterprises with massive IT budgets. A mid-sized educational institution with approximately 800 employees implemented Fabric's AI capabilities and saw their reporting backlog decrease by 76% within 4 months. Their small data team of 3 people now supports the entire organization effectively by focusing on data architecture and governance, while business users handle most of their own reporting needs. The future roadmap, what's coming next for AI in Fabric. While organizations of all sizes are seeing tremendous benefits today, what Microsoft has planned for Fabric's AI capabilities tomorrow looks set to completely transform how we work with data. The roadmap Microsoft has revealed shows that today's impressive features are just the beginning of a much more ambitious vision. Looking ahead to the next 6 months, Microsoft is set to expand AI skills compatibility beyond just lakehouse and warehouse data sources. This highly anticipated update will bring natural language querying to a much wider range of data formats, including direct connections to third-party databases and SaaS platforms. For organizations that have hesitated to implement AI skills due to their existing data architecture, this expansion eliminates a major barrier to adoption. One of the most exciting developments on the horizon is the introduction of conversational memory within AI skills. Currently, each query is treated as a standalone interaction, forcing users to repeat context when asking follow-up questions. The upcoming update will allow the system to maintain context throughout a conversation, making interactions feel much more natural. Imagine asking, "How did sales perform last quarter?" and then simply following up with, "What about the quarter before that?" without needing to specify what you're looking for. This capability will dramatically improve the user experience, particularly for business users who are exploring data to find insights. Microsoft is also enhancing the query feedback mechanism to create a learning loop. In the next major update, users will be able to provide detailed feedback on query results, indicating whether the AI correctly understood their intent and suggesting improvements. This feedback won't just be sent to Microsoft, it will actively improve the performance of your specific Fabric implementation, essentially teaching the system about your unique business language and data structure. Organizations that invest time in providing this feedback will see dramatically better query accuracy over time. The development team is working on significant improvements to the way AI skills handles complex calculations and time intelligence. The upcoming release will enable more sophisticated financial modeling, cohort analysis, and year-over-year comparisons through natural language. This means financial analysts will be able to ask questions like, "What's our customer acquisition cost trend by marketing channel?" adjusted for seasonal variations, and receive accurate results without writing complex DAX formulas or SQL queries. Another major enhancement coming to Fabric involves the integration of industry-specific knowledge into AI skills. Microsoft has been training specialized models that understand the terminology, metrics, and common analysis used in healthcare, financial services, manufacturing, and retail. Organizations in these industries will soon be able to activate these specialized models, enabling their users to ask questions using industry standard terms and receive results that align with established practices and regulations. For data engineers and analysts, Microsoft is expanding the range of AI functions available in notebooks. New functions being developed include time series forecasting, anomaly detection, and relationship discovery. These will allow technical users to identify patterns in historical data, predict future trends, and automatically discover connections between different data entities, all with minimal code. This expansion aims to bring advanced data science capabilities to data professionals who may not have specialized machine learning expertise. The Copilot experience in Power BI is also getting a major upgrade with new visualization suggestion capabilities. Rather than just creating visualizations based on user requests, Copilot will proactively recommend alternative ways to represent data that might reveal different insights. For example, if you're looking at sales by region in a bar chart, it might suggest a map visualization that reveals geographical patterns you hadn't considered. This capability essentially puts an experienced data visualization expert at every user's fingertips. Microsoft is also working on expanding real-time analytics capabilities with new AI-driven pattern recognition. This will enable organizations to automatically identify emerging trends, potential issues, and unusual patterns in streaming data without having to define exact rules in advance. For example, a manufacturing operation could automatically detect subtle changes in equipment performance that might indicate future failure, even if those specific patterns weren't explicitly programmed as warning signs. Integration with Microsoft's broader AI ecosystem is another key focus area. Plans include deeper connections between Fabric and the Azure OpenAI service, allowing organizations to more easily incorporate their own custom AI models into their data workflows. You'll be able to use specialized models trained on your proprietary data alongside Fabric's built-in capabilities, creating truly unique AI-enhanced data experiences that align perfectly with your business needs. One of the most interesting developments on the horizon is what Microsoft calls multimodal analysis. This capability will allow Fabric to work with a combination of text, numerical data, images, and even video content in a unified way. A retail organization could, for example, analyze customer sentiment from survey text alongside store layout images and sales figures to understand how physical store design impacts customer experience and purchasing behavior, all in a single integrated analysis. For organizations concerned about data governance and compliance, upcoming features will introduce more granular AI controls. Administrators will be able to define specific boundaries for AI-generated queries, limiting them to approved data sources, enforcing stricter verification for certain types of queries, or requiring human review before executing particular kinds of analysis. This will help organizations balance the benefits of AI accessibility with their regulatory and security requirements. Microsoft is also developing specialized collaboration features designed specifically for AI-generated insights. These will allow users to share, annotate, and build upon AI-discovered patterns in a collaborative workspace. When someone discovers an interesting trend through AI skills, they'll be able to share that insight with colleagues who can then ask their own follow-up questions, preserving the full context and creating a shared understanding that drives better decisions. Understanding this roadmap is crucial for organizations planning their Fabric implementation strategy. Many companies are currently debating whether to invest in custom solutions for specific data challenges or wait for native capabilities from Microsoft. With these upcoming features in mind, it often makes sense to focus custom development efforts on truly unique business processes while leveraging Microsoft's built-in capabilities for more common needs. To stay informed about these rapidly evolving capabilities, connecting with the broader Fabric community is essential. With over 2.4 million members worldwide, this community offers valuable insights about upcoming features, implementation best practices, and creative ways to leverage Fabric's AI capabilities. The Microsoft Tech Community Forums, monthly release notes, and the official Fabric blog are all excellent resources for staying current with the platform's development. Organizations that maintain awareness of this roadmap can make more strategic investment decisions, potentially saving substantial development resources by aligning their implementation timeline with Microsoft's feature releases. For example, a company planning to build custom natural language processing for their marketing data might reconsider upon learning that Microsoft will deliver similar functionality natively within 6 months. We've covered a lot of ground today, exploring the AI capabilities inside Microsoft Fabric that are quietly revolutionizing how organizations work with their data. What makes these features so powerful isn't just their technical sophistication, it's how they're democratizing data access across entire organizations. If you take one thing from this video, remember this. Start small. Pick one AI capability we've discussed, apply it to a specific business problem, and demonstrate its value before expanding. I highly recommend taking advantage of Microsoft's 2-month trial with that 17,000 capacity allowance. It's the perfect way to experience these transformative AI features in your own environment without any financial commitment.